Hello, you're welcome. All right, so introduction to calculus. Okay, so we're going to start by defining calculus. Now, calculus is the branch of algebra that studies the rate of change. Okay, so of course, you know very well that change is a constant into life. So every area of life actually undergoes change. Okay, so the study of this rate of change, okay, to any area of life or even any field of study is what, okay, that branch of algebra that studies that is calculus. All right, so now calculus in algebra is being divided into two, and of course one of them is differential calculus, where we study differentiation, and the other is the integral calculus, where we study integration. Okay, so basically in calculus we study differentiation and of course integration. Now I'm going to illustrate what we basically do in differentiation. Whenever we are differentiating a function, what we do, and of course in integration what we do. Now, in a simple term, in differentiation we actually scatter a very large amount of change, okay, into smaller small unit of change, okay, basically for study. So in differentiation we actually scatter, okay, it involves scattering, while in integration we actually gather small amount of changes, okay, now to produce a substantial amount of rate of change. All right, so in integration basically we do gathering. Okay, so it's just the basic difference between integration. Of course, two of them are opposite, okay, to each other. So now in the course in this tutorial, okay, of course we're going to start with the very first, which is differentiation. So we are starting with differentiation. Okay, so that's gonna be the very first topic. Let me clear the screen so that I will start with differentiation. Okay, so now what is differentiation? Okay, now differentiation basically is a process, okay, of computing, the process of computing derivative. Okay, so that process of computing derivative is what differentiation, okay, is. Now the question is, what is derivative of a function? Okay, what is the derivative of a function? Now the derivative of a function, okay, is actually defined as the smallest rate of change of that function. Okay, the smallest rate of change, the smallest rate of change you can ever get, the smallest rate of change. So invariably now, okay, if I have y being a function, let's say y is a function of x, all right, then I'm being asked to get the derivative of this function. Okay, all I need, the derivative of this particular function, y being a function of x, is the smallest rate of change. So if I can get the smallest rate of change of y with respect to x, then invariably I have actually evaluated derivative. So please take note, okay, derivative is the smallest, very small rate of change. So in fact, why do call it smallest? Because that the smallest means that there's no smaller rate of change you get out of derivative. All right, so now mathematically we actually express derivative as dy dx. Okay, so dy dx of a particular function is the derivative. That's how we express it, and it's the smaller rate of change. And in mathematics, anytime we want to okay, describe the smallest aspect of anything, any particular relationship, okay, we use limit. Okay, so the y dx, which of course is the derivative of this function, is the limit of this is change, the change of y with respect to the change of x, okay, as change in s actually approaches 0. So when change in s is very small, that it actually approaches 0. Okay, the limit of this change, the change in y over change in x, and of course you know very well that delta y over delta x, the place you get this delta y over delta x is actually from the gradient of, okay, a curve. Remember, okay, gradient of a curve given as a changing y, that is the y-axis, all over changing x. Okay, so now the limit of this change, when the change in s, okay, becomes so small that it actually approaches 0, is what we call the derivative of the function. So please take note of this. So now this particular method of actually computing derivative using gradient, okay, using the gradient is basically the is a method known as the first principle. Okay, so first principle, we employ the gradient of a particular curve to compute the derivative. So this is the first principle. All right, so please take note of this, the y dx. So if I'm actually asked to evaluate the derivative of the function y with respect to x, okay, invariably I'm being asked to find the dy dx of this particular function. Okay, so I hope that is well understood. Okay, so I hope that is well understood. Now let's see how this actually works. So now, how do we pronounce this? Okay, we pronounce this, of course, the way the s are pronounced it now. So what is the meaning? This simply means the y the x is actually the derivative, okay, is actually the derivative of y then with respect to x. The derivative of y with respect to x. So we simply, anytime you are being asked to find the derivative of a function, okay, you are actually finding the derivative of the dependent variable. Remember, y is the dependent variable, ys is the independent variable. Okay, so it's always the derivative of the dependent variable with respect to the independent variable. So just let's say we have, it is being, the function is of this form, okay, v is equal to function of t, f of t, okay, and you are being asked to find the derivative of v. So the derivative of v with respect to t is actually given as dv dt. Okay, so that's the derivative of v with respect to t, which of course is still going to be equal to the limit of change in v all over change in t. Then of course, as a change in t approaches 0. So please take note of that. So that is called the first principle. So now we are going to look at how we okay, use first principle to evaluate the derivative. So basically the formula from of first principle is what you see here. Okay, evaluating derivative from the gradient of a curve is the method of first principle. So let's actually look at how we do that using first principle. So the very first thing we're gonna, okay, do is to evaluate a derivative by first principle. All right, so now let's look at example. Okay, using first principle, evaluate the y dx of the following. So I'm gonna start with a y is equal to x, b y is equal to 2x, then of course c y is equal to x squared. So I'm starting with the very simple functions. Okay, very simple functions. So let's start solution. So remember, if I wanna, the function here is y is equal to x. Okay, if I need to find the derivative of this particular function, okay, which of course is the y dx, using the first principle, then I need to introduce change. Already this function doesn't have change, okay, so I need to introduce change to both the dependent variable and to the independent variable. Okay, so how do I do that? So I'm gonna introduce change y plus change in y, and also do that um to the x variable. Okay, x, then also introduce change to that function, okay, plus change in x. Now remember, I need, the whole idea is so that I can get my delta y all over delta x, because it is only when I have the delta y all over delta x that I can find the limit, and once I find the limit, then that is my derivative. Okay, so now what do? I want to rearrange this equation. So first I will take y to the right side of the equation so that I have only delta y at the left hand side. So delta y is going to be equal to x plus delta x, then minus y. So already we know that y, okay, from what we have here from the function, y is equal to x. So that means delta x is going to be equal to x plus delta x minus y, which of course is x. So collecting like terms together, x minus x is equal to 0. Okay, so I'm left with delta y equal to delta x. Okay, so now since I've actually simplified, I can now divide both sides. Okay, or divide through, because I'm looking for delta y all over delta x, so I have to divide everything, divide through by delta x, so that I can be able to get my gradient, right? Divide through by delta x, excuse me, pardon me, by delta x. So that's what I'm going to do now. So I'm going to have delta y divided by delta x is equal to delta x still divided by delta x. Okay, so here we are. Okay, so I'm having delta y. Now I've got my delta y over delta x, which of course is the gradient. Remember, in the first principle, okay, the very first thing we need is our gradient. Okay, so by the time we find out we have our gradient, we can find the limit. Delta s divided by delta s will give me 1. All right, so this is my gradient. So I can now, from the gradient, I can get my dy dx. Remember, my dy dx, okay, is always equal to the limit of my gradient. The limit of my gradient, delta y all over delta x. Okay, as delta x actually reduces to 0, approaches 0. Okay, then so what does that mean? So invariably now that's going to be the limit of, what is my delta y over delta x? That's going to be the limit of 1. Okay, limit of 1 as delta x approaches 0. You know very well that the limit of a constant, we've already treated the limit of a constant, okay, is always that constant. So the limit of 1 is what? 1. So invariably the ds, the derivative of x, okay, will always yield 1. I hope that is well understood. Okay, now I'll still need to solve the second part of the question. So let's solve that. It's still going to be easy. Okay, so here I'm having y is equal to 2x, and you know what I'm going to do? I'm going to introduce change to the two variables. So it's going to be y plus delta y is equal to 2. Okay, 2 times x. Remember, I'm introducing change to this x, right? I'll still need to multiply by 2. So that's going to be 2 times x plus delta x. All right. So you know what I do? Okay, I have to make delta y the subject type, take y to the other side, and of course I have to open this bracket. Open this bracket, that's going to be 2x. 2 times delta x, that's going to be equal to 2 delta x. All right, then of course minus y, which of course delta y is going to be equal to 2x, okay, plus 2 delta x. Y is 2x, remember that already. So collecting like times 2x minus 2x, that is 0. So I'm left with 2 delta x. So delta y is equal to 2 delta x. So of course, having gotten to this point, I know what we do. Okay, at this point, remember the whole idea is for me to get my gradient delta y over delta x. So I'm dividing both sides by delta x. Also divide this by delta x. So delta x cancels delta x, right? So I'll have my delta y over delta x to be equal to 2. Okay, so how does now give me my derivative? So this now, the gradient now becomes derivative when I apply limit to what I got. Okay, when I apply the limit of delta y all over delta x. Okay, as delta x approaches 0, and of course you know that this is actually a constant. Okay, and that will definitely be the limit of delta y over delta x is already 2. That's going to be the limit of 2 as delta x approaches 0. Okay, so of course the limit of a constant is still that constant, that is going to be 2. I hope that is well understood. Okay, so the last but not the least, I'm still going to do a lot of work on the first principle, a lot of questions. Okay, but this is just a starting point. So this will help you understand the basics of first principle. Okay, so now I'm having y equal to s squared. Okay, so the same thing happens here. I introduce change. Y delta y is going to be equal to, now this time around, now that's going to be x plus delta x before I now have to square it. Okay, I have to introduce change to the x variable. Okay, before I now square it. All right, so of course you know what happens here. Delta y is going to be equal to bracket open x plus delta x, then minus delta y. Okay, minus y, please pardon me, minus y. So of course you know very well that I will have to expand this square. Okay, x plus delta x. So if you expand this, definitely you're gonna have x squared, then plus 2 times x times delta x, that is 2x delta x. You can do that. Okay, you can do that in a, if you don't know how to use this shortcut, you can do that in a rough. All right, and of course plus delta x squared. So that is the expansion of this bracket. Okay, x plus delta x all square, right? Now of course you know that this is same thing as x plus delta x, then multiply by x plus delta x, just in case you want to expand that to yourself to confirm whether it will give you this. All right, so now minus y, of course what's my y? My y is s squared. Okay, so that's s squared. So what do we do now? What do we do now? Like times s squared minus s squared, is 0. So I'm left with 2x delta x plus delta x squared. Okay, so now I divide both sides by delta x. So I also divide this by delta x. This is also being divided by delta x. Okay, so now delta x cancels delta x. All right. Here I'm having 2x then of course plus delta s squared divided by delta s, that's just delta s. Okay, so having gotten my gradient, I can now get my derivative, which is dy dx, which already we know that is going to be the limit of my gradient. Okay, the limit of my gradient as my, excuse me, as my change delta x actually approaches 0. And if I should do that, okay, so that simply means that I'm going to find that this is my gradient, delta s plus 2x plus delta s. Okay, that's going to be the limit of 2x plus delta x. Okay, then of course as delta x approaches 0. So how do we find the limit? Of course, if we find the limit of this function as delta s approaches 0, that means delta x will definitely be equal to 0. Okay, because I have to substitute 0 into delta x. All right, so that simply means that what I'm left with 2x, so that only gives me what, 2x of course plus 0. Okay, which of course is 2x. Okay, so basically that's the first principle. Okay, and that's how we apply first principle. So this is just a simple question, okay, that I solved, simple derivative I solved using first principle. So we will still gonna look at some complex derivative, and that will be in the next video. Right, see you in the next video. Thank you very much.